All right, guys, so at this point in Unit 4, we've seen 3 different methods that we can use in order to solve quadratics. The first method was factoring, the second method was by square roots, so we're completing the square, and the third method was quadratic formula. So now we need to start to talk about when should we use one method over the other. So that's what this section is all about. So let's take a look at some examples. So for numbers 1 through 4, we're going to decide which of the 4 methods, or 3 methods I should say, would be the most efficient, and then explain our reasoning. Okay, now these are really in order of the way we've seen them. So they're in order 1, 2, and then 3. And really the reason why they're presented in that order is that's really kind of the way that we would prefer to solve them. If you think back to factoring, factoring makes solving quadratic equations really easy. You just use zero product property and you're done. The next best thing was square roots if we could, and if we couldn't, we completed the square. And then kind of as a last resort, if nothing else works, that's where we're using quadratic formula. So let's take a look at number 1. Let's kind of think about how we would solve this equation. So we've got 5x squared plus 20 is equal to 4. Now if we're going to solve by factoring, we need to get our right side of the equation to equal 0, and that would be 5x squared plus 16 equals 0 when you subtract 4 from both sides. The problem with this is for factoring, you've only got 2 terms, and there's not a greatest common factor, so that's not going to help us, and it's not a difference of squares. So factoring is not going to work. So the next thing we should try is square roots. In other words, if we were to want to solve this by square roots, really instead of getting it to equal 0, we'd want to try to get x squared by itself, which would mean subtract 20 from each side would be negative 16. Divide each side by 5 is negative 16 fifths. And then take your square root, and actually that looks like it's going to work. In fact, it will work. So the best method to use in the case of number 1 would be to solve it by square roots. Now the reason why that works, that we're able to solve by square roots, is that there's no bx term. So when you look back at your equation, there is no bx term. What I mean by that is there is no middle term. It's also worth pointing out that this equation is not factorable. Okay. Let's go ahead and take a look at number 2 then. So again, we're going to start the same way. We're going to start by trying to factor in each of these problems. And so if we're trying to factor, we do have all 3 terms this time. So we're looking for numbers that multiply to be 21, that add to be 10. Actually, those are pretty easy to find pretty quickly. Is that you'd be using positive 7 and positive 3. And then to solve, just set each of those equal to 0. You get negative 7 and negative 3. So in this case, it turns out that factoring is the best method to use. And for reasoning, all you'd have to say there is that the equation was factorable. Next, for number 3, we've got x squared plus 8x is equal to 5. Obviously, if we are going to try to solve this by factoring, we need it to equal 0. So if we subtract over the 5, then we're looking for numbers that multiply to be 5, that add to be 8. And pretty quickly, you're probably going to notice that factoring is not going to work. So factoring out as an option. So then let's think about square roots. If we've got x squared plus 8x minus 5 equals 0 once again, the problem this time is that there is a middle term. And if there's a middle term, we're not going to be able to use square roots. So that option is off the table as well. Okay, so our next option is completing the square. So we'd be looking for what number would we add to the left side to make this a perfect squared trinomial, and what number would we add to the right side to make the equation still balanced. And actually, 8's an even number, so that works out really well. B is 8, b over 2 is 4, and 4 squared is 16. So we would just have to add 16 to both sides, and we're already on our way to solving this problem. So in this case, completing the square would be our best option. For reasoning, we're going to say that that's because it was not factorable first, that it had a middle term second, so it has the bx term, And finally, that b value is an even number. Now, obviously, we've seen if it's an odd number, we can still make it work, but it's sometimes a little bit more difficult. All right, so now we get to number 4, and you can probably guess what method we're going to be using here. But let's go ahead and check all the other methods and make sure that it does in fact need to be solved by quadratic formula. So when we take these and multiply, so we've got 3 multiplied by negative 74, we get negative 222. So we'd be looking for numbers that multiply to be negative 222, that also add to be negative 5, and I will spare you the headache and let you know that there is no way that that's going to work. So for reasoning so far, we would have to say we're not going to be able to solve by factoring because it's not factorable. Also, notice that it does in fact have a middle term. So it has the bx term. The square roots is now off the table. Also, notice that b value of negative 5 is odd. So our b value is odd. And also notice that a does not equal 1, which really makes completing the square very difficult to do. So then quadratic formula, that's our last resort. We're just going to have to grind this one out, putting that into the formula. Really no other reasoning you have to give other than none of the other methods would work in this case. So now that we've also seen quadratics in different forms, let's talk about comparing those different forms. So what I've got for you on number 5 is that we're going to fill out some information based on the following equation in its different forms. So this equation is the same. In fact, if you wanted to check, multiply out b or c, and you'll get a as your equation. So this is all the same equation. It's just that the first one is in standard form, the second is in factored form, and the third is in vertex form. So really that's the only difference between these equations. I'm also missing a characteristic, so if you could add y-intercept to the bottom of each of these tables, we're going to be talking about that as well. Okay, so what we're going to do is we're going to go through and try to identify which characteristics are easy to find in each of the different forms. For opens, actually that's pretty easy to see in each of the equations. For opens, you just look at what number is the leading coefficient or in front of x squared. In this case, that's a 1, and in all of those cases, that 1 is positive. That tells us that our graph opens up. Now, any graph that opens up, no matter where it is on the coordinate plane, is always going to have a vertex, which is a minimum. So that should be pretty easy to tell for all 3 equations as well. So now we're at vertex, and while yes, you can find the vertex for standard form and for factored form, vertex is obviously going to be easiest from vertex form. All you have to do is change the sign of what's inside the parentheses and keep what's outside. The same is true of axis of symmetry. That's easiest in vertex form because you just copy down the x value for your vertex. Again, we have ways to find that for A and B as well, but easiest for vertex in part C. For maximum value, also easiest in vertex. Obviously, you just look at the y value for your vertex. It's also worth pointing out that that is just a number. A lot of people on the quiz lost points because you had y equals -4 rather than just -4. So make sure for the value that you are just listing the number. For domain, at this point, we've probably come to the realization that the domain is always all real numbers. That should be basically a free point that everybody gets anytime we take a quiz or a test by now. Now for range, that's going to be one that's hard for all 3 forms. Probably the easiest is in vertex form. If your graph is opening up and the minimum value is 4, then that means that all the y values have to be more than 4. So that's going to be easiest in vertex form. So far, vertex form has probably been the easiest form to work with, giving us the most information right away. But for number of real solutions, this is where it's actually probably easiest in factored form. For number of real solutions, look at your number of factors, and that's going to be 2. That's also going to mean roots are easiest in factored form. Just take the opposite of the numbers in parentheses or set them equal to 0 to be careful. And that's negative 6, 0 and negative 2, 0. So at this point, you're probably sitting there wondering, well, what is standard form good for? And that's where I had to add in that y-intercept. Remember that the y-intercept is just going to be the c value of your equation in standard form. So that would be 0, 12. All right, so looking at these three boxes, it's probably easiest to notice that vertex form gives you the most information, gives you everything except for the roots and y-intercept just by looking at the equation. But what I really want you to see is that if you put all these forms together, going across each of these topics, is that if you use all three forms together, you're going to get at least the information for each of those different characteristics. So, the question based on the above information, does the form of the equation change any of the characteristics? The answer there is no. The last thing I want to talk about in our notes for today is how to compare equations by looking at their graphs. So we're just going to write a few sentences comparing the vertex, number of solutions, etc. for three different equations this time. Equation A as given, B, and C. In fact, I'm going to go ahead and graph those using Desmos. In fact, I've got those for us right here. The nice part about Desmos is it does color code. So for those that like the colors and can see those, it's kind of nice because then you can look at the different equations and their graphs together and know which parabola matches which equation. So as I'm looking at these, I'm just looking for what are some characteristics that I notice. For example, the first graph, graph A, which is in red, opens down. The other two graphs open up. So as far as comparisons go, that would probably be the first thing I would say, is that equation A, in fact, don't even really need to write out equation for the rest of these. I'll just write the letters. So equation A opens down, while both B and C open up. The next thing I might want to compare is the number of solutions. Notice that the equations A and B both have two solutions since they cross the x-axis in two different places, whereas equation C has no x-intercepts, and so it has no real solutions. So that would maybe be the next thing I could mention, is that A and B have two solutions or x-intercepts, whereas C has none. Now, typically, I'll want you to write probably about 3 sentences for these types of questions. So that would be 2 different comparisons. For our third comparison, let's just look to see something else we can notice. We could say that the vertex for A is a maximum, whereas the vertex for both B and C are minimums. So we can go ahead and write that as well. So equation A has a vertex that is a maximum, whereas B and C have minimums. Now, obviously, there's other things you can compare as well. Going back to the graphs, obviously, we could compare the y-intercepts of each of our graphs, being that 2 of them are positive, 1 of them is negative. Lots of different things that you can do to compare your graphs. All right, guys, that is it for these notes in 4.4 with best method. In section 4.5, I'm going to show you how to use your graphing calculator, TI-83 or TI-84, in order to graph quadratics and find all of the key characteristics. And then we'll also talk about how you can actually take a graph and write an equation from the graph. Until then, have a great rest of your day.